This is Avanish Tripathi. I am a faculty at Department of Energy Science and Engineering, and I work in the area of power electronics. The applications where I orient my research work include electric transportation, which is basically related to the motor drives, and grid-connected converters. When we talk about electric transportation, primarily I focus on the railway transportation and any other high-power electric vehicle segment. When we talk about grid-connected applications, there are several segments over which we are trying to work on. One involves the main theme of our department, that is renewable power generation through solar and wind, and the integration of these resources with the grid. So we work in the area of integration of renewable resources with the main grid, the microgrids, and also towards some niche application areas which involve the black start problem for the smart grid or the main grid network. We also work in the area of electric vehicles, which include motor drives, which is already mentioned, and also the EV chargers. So particularly what I am targeting are the high power chargers which can provide the EV charging in a very short time.
This experimental setup is designed for parallel to two-level voltage source inverter fed induction motor drive. Two sets of three-phase inductors are connected between the voltage source inverter and induction motor. Same experimental setup can be configured as active harmonic filter based induction motor drive. Both drive worked in a closed loop vector control mode.
So the objective of this work is to generate the electricity from a hydro turbine, but the problem there is voltage is not regulated and the frequency is also fluctuating. So to get a regulated voltage 220 volt and 50 Hz, we have designed a hydro inverter which gives the 220 volt and 50 Hz output that can be given directly to the household application.
My research area is on PMSN drive for high-speed application. Typically, the power rating of the motor falls in few kilowatts to megawatt. Depends on the what the application we are preferring for high speed.
This is a scaled-down setup of traction converter from the Indian Railway propulsion system, that is WAG9. So this setup consists of a front-end converter, which is basically a control rectifier, which is feeding to three-phase inverter motor drive, which is feeding to 3 squirrel cage induction motors. So the entire power level of the system is 33 kilowatt.
This is a hybrid microgrid setup. It consists solar PV power, wind energy, and thermal power. Particularly in this setup, we are focusing about the black start strategy and high power transformer energization. This setup is grid connected, solar supported DC fast EV charger emulator, which consists of grid connected converter, solar PV emulator, and battery emulator with the high power, high frequency isolation transformer and inductors.